today we are going to learn about mean absolute deviation. So we know what a mean is, and if we think about absolute zero, which we've learned about, we can put those two together to find out what mean absolute deviation is. Now sometimes you'll see mean absolute deviation listed as MAD, M-A-D. That will be the abbreviation on your test, so just so you know. Keep in mind you may use any notes that you have on your test, so be sure to take good notes during this. So first off, we're going to define what the mean absolute deviation is, and it is the average, which makes sense because it's a mean, and distance because of absolute value, the average distance between each data value and the mean. So if a data set has a low mean absolute deviation, then this means that the data values are relatively close to the mean. And if the mean absolute deviation is high, then the values are spread out and far from the mean. So in order to find the mean absolute deviation, what we need to do is first to find the mean of your data points, which we know how to do, or we should know how to do at least. Then we need to calculate how far each number in the data set is from the mean, add up all the values from step 2, and divide by the number of data values. This kind of takes a while, but if you do it step by step in a very procedural way, you'll find that it isn't too terrible. So we have an example. We have a data set here, and what they did for us is they have this neat little table here. If I can focus the camera. So here are data points. We have 1, 6, 8, 5, 5, 1, and 2. They went ahead and put it in order from least to greatest. What we need to do is find the mean. Remember, how do we find the mean? We need to add up all of these numbers and then divide by how many numbers we have. We have 1, 2, 3, 4, 5, 6, 7. So we're going to add those up. So if I do that, I get 28. And if I divide that by 7, my mean then is 4. So in this table, I'm going to write 4 for every cell in this column, because that is my mean for this data set. Okay? Now this column is how far, or the range, is each piece of data from the mean. So if I look at more closely, I have a 1 here and a 4 here. Well, the distance between 1 and 4 is 3. The distance between 6 and 4 is 2. The distance between 8 and 4 is 4. 5 and 1, or I'm sorry, 5 and 4 is 1. 1. 1 and 4 is 3. 2 and 4 is 2. Now that we've done that, we need to go back up. Now we're on step 3. Add up all the values from step 2. Okay, so what we need to do is add up all of these values. And you see here, underneath this handy table, they've put sum. Well, the sum means to add them all up. So if I add 3 plus 2 is 5, plus 4 is 9, 10, 11, 14. My sum of all of those numbers is 16. Okay? And now what this is over here, keep in mind, MAD stands for mean absolute deviation, equals the sum, which we found is 16. And this N stands for how many numbers do we have in our data set. Well, if I go back up here to find my mean, we had 7 numbers in our data set, or I can count them. 1, 2, 3, 4, 5, 6, 7. So I have 16 divided by 7, and if I go through and do the division, I end up with 2 and 2 sevenths, which is 2 and 29 hundredths. So this, or this, would be my mean absolute deviation. All right? Okay, let's do another one. Sorry, I have to keep refocusing my camera. So it says find the mean, median, mean absolute deviation of the numbers below. Well, the first thing we need to do is put them in order, and I'm going to go ahead and put them right in the table here. Now, they actually have room for 7 numbers, but there's really 8, so I'm going to kind of extend this table to fit one more number. So I should have, in order from least to greatest, 3, 4, 5, 6, 7, 11, 12, and 12. Okay, now I can go back and I can easily find my mean and my median. Okay, so my median again is my middle number, 1, 2, 3, 4, 5, 6, 7, 8. So my median is going to be the average of 6 and 7, which is 6.5. And my mean, I need to add all of these up and divide by 8. So when I add all of them up and divide by 8, I get 60 divided by 8, and that is 7.5. Now if I go down here and I look, I can fill in this middle column with my mean because I have that. So 7.5 all the way down. So really, this part is nothing new because you're used to finding the mean of numbers. And this part really isn't anything new either because it's just the range between these two data points. So if I find the range between those two, or the distance between those two, I would have the difference between 7.5 and 3, or you can take a calculator and do 7.5 minus 3. Keep in mind with decimals, with adding and subtracting decimals, we line up our decimal, and we get 4.5. 3.5, 2.5, 1.5, half, 3.5, 4.5, and 4.5. Now what I need to do, at the bottom of this table you see sum. And what does sum mean? Well, it means add. So I need to go ahead and add all these numbers up. When I do that, I get 25. So that's nothing new either because that's just addition. What is new is this last part. So we need to take the sum, which we found was 25, divided by how many numbers we have, which is 8. So when I do 25 divided by 8, I get 3 1/8, which is the same as 3.125. Okay? All right, number 2. I would like you to do number 2 or try number 2 on your own. And then the last page, so if I flip this over, it asks you some questions. So it's measure of central tendency and variability. Which one do you think is going to be the best one to use when describing some data? It kind of lists it right there to go in order. Don't worry about outliers. We haven't really talked about outliers, but I want you to focus on 3. So again, do this page on your own, answer the back, and then you'll have some problems in your book to do.